right, let's start this. Thank you for being here. It's a full room. It's a real project that we're presenting here today, so we really hope you enjoy it. Yeah, it's the real stuff now, and we are proud to show you what we've been doing in the past almost 3 years with Kafka in the investment segment. It's a stock market trading, and we're going to share a little bit about it. I'm Marcoss Maia. I'm from Brazil, but I've been living in Amsterdam for around four years, more or less. It's a great place to be. ING, ING is a very innovative bank. My background is in distributed computing. I work with application servers since before the 2000s. A lot of message-oriented middleware in my career, mostly with big customers. I worked for now non-existent companies like BA and Borland. That if you're a bit older, you know them. The JBuilder before you use IntelliJ was an amazing tool, and WebLogic Server that was acquired by Oracle later. I also worked in a worldwide team with IBM for WebSphere for many years, so I really worked with really huge customers on the finance sector for a long time. And yeah.
Yeah, welcome everybody. My name is Tim van Baarsen. I'm working 2.5 years for ING now. I'm interested in event-driven architectures, using Spring since the early days, occasional speaker on conferences and meetups, and yeah, we did a quite interesting project on Kafka. That's really happy to share that knowledge today with you guys.
So to continue a little bit about ING, ING is the most innovative bank, probably one of the most innovative banks in the world. It's a bit different than any bank that you might have worked or known before. It's really pushing to be an IT company for many years now. So it's really doing cutting edge technology, trying to flatten the structures and building a technical career path for developers. It's really pushing that direction. It's present in over 40 countries. There is over 1,500 vacancies open, so if you are interested, you can take a look at it. Over 20 different countries, so it's quite interesting. And yeah, let's start a little bit about our agenda today then. So we are going to explain a little bit about our use case, why we start this project in the first place. About MiFID II, basically was the kickstart for us. We're going to show a little bit about our mobile investments application, over our architecture. By the way, everything we're showing here, as I mentioned, it's a real thing. It's in production. It's working. Some of the code, it's not, but we're going to get there. We're going to do a demo. We're going to talk about metrics and monitoring, which is extremely important for us. Kafka Streams, local development, how we do it. Lessons learned, and we're going to be open for a few questions, hopefully, if we have time.
Exactly. Yeah, so just a quick disclaimer before we start, because within ING we have a lot of regulations, we have security measurements, so we could not actually show you the real production code today. But yeah, we wouldn't come up here on the stage just only showing you slides, so we really would like to show you real code. So we created basically, it started as a pet project, but grew out to some kind of really nice lab project that works for us. And that's actually what we're going to show you today. But it's inspired on the work we did within ING, and yeah, we will promise you it's at least as interesting as the real project. Maybe even better, because if you do things for the second time, you always make better decisions. So we're really happy to share that knowledge with you today. Yeah, before we continue, the investment domain is quite a complex domain. So we would like to keep our business lingo as limited as possible. But if you heard the name or the term tick, please remember this slide. Then we talk about a price update on the stock. So we are in the investments department of ING. Yeah, where it all started? It started with a regulation, and that might really boring, but for us it was really a nice journey to get started with Kafka. So the European Parliament came up with this regulation after the financial crisis to actually protect the customers in the end, to avoid losing a lot of money on investments. And just to emphasize, not only ING had to implement this regulation, all European banks had to do this. And yeah, the actual regulation is quite a big book, right? We only show you a really small part of that today, and actually the most interesting part that worked for us. So basically, our requirement is literally the title of this slide, inform our investment customers when a stock drops in price 10% at the end of the day. So we send them out an SMS or a push notification in the app. But yeah, at the end of the day, you probably lost already quite a lot of money, right? So we sat down with our product owners, with people from the business, and we said, okay, this is the requirement from the regulation, but we can do better, right? We should do this in real time, because then our customers can act accordingly and hopefully save some money. So that's where we started. To give you a bit of context, I would like to show you some screens of our mobile investment app that our customers are using a lot. Of course, we also have a web-facing interface, but we see more and more people are using the mobile application. So let's consider you have a investment account within ING. You have a lot of stocks in your portfolio, and you can see your stocks, and you would like to set an alert on one of your stocks in your portfolio. So you can see those alerts that you're going to create. You can create alerts, you can delete them and have an overview of them. That's pretty straightforward. So next to the required 10% drop in price, the business also came up with nice ideas. So we took a quite positive approach to, on top of the regulation, also add basically features for the customer, because if the price goes up, you might want to sell it because you can actually make some money. And then they ask us, oh, can you also do this on a specific price? So not only on a percentage, but also on a specific price. So for example, if the ING stock reaches the price of, let's say, 12 euros, I would like to get a notification so I can do something with that. And the customer can not only create one notifications, but can basically set multiple notifications. So they get notified. And it's a bit annoying, right? If you create an alert and you have to log in again when it is matched. And so they also ask us, can you create recurring alerts? So customers don't have to log in and create those by hand. So along the way, a lot of requirements came in, and step by step, the project became a bit more complex. And then the most tricky thing came at that time that we start implementing, because they say, realize if you would like to do this real time, we are dealing with a constant stream of price updates, ticks from the market, and that can go up between 2,000 up to 12,000 a second, especially as Trump is tweeting around, and we see it's it can go crazy, right? So we have to be prepared for that. So where did we start? We didn't initially thought about Kafka in the beginning. We heard a lot of fuss about it. It was happening and trending. But we first did a lot of POCs. We tried to store data in Elasticsearch. We played around with Spring Batch. But in the end, we quickly realized that we needed some kind of streaming platform to deal with this huge amount of data coming in. And on the other hand, matching this against the thousands of alerts created by our customers. And we cannot stop this. We would like to do this real time. So that's where our journey began. On our team, we had a really experienced Spring knowledge, Spring Boot. And we found out that within ING, there was a team managing a Kafka cluster already for years. So they were really mature in managing this Kafka cluster. For us, it was really convenient because we didn't have to worry about this Kafka cluster. We didn't have to manage it ourselves. So that's actually where our journey started. Before we going to show you some code, some live demos, I would like to quickly show you how our overall architecture looks like, to get some pictures, because you will see some of the applications running. So let's maybe start with our end result. We would like to send out a notification as soon as possible to our customers. And to do that, first the customer needs to create an alert, and of course we create alerts when they buy stocks. we have the application, the web application, and there are also advisors that can, on behalf of the customer, create alerts, because we still have also people calling on call centers, get advice. So also the advisors should be able to create alerts on behalf of the customer. So that's basically where it starts. So we have a Spring Boot 2 application that's basically primarily offering a REST interface, and in the end store the alerts for the customer in the database. That's pretty straightforward. Then we have another component, and that component is basically responsible for receiving those price updates from the market. And this one is going to push the constant stream of ticks on Kafka. So far so good. I mean, producing to Kafka is pretty easy, so that will work fine. To run Kafka, you need the zookeeper, and we also use a schema registry. We will go into that later on, but for now this was managed for us, so that was pretty nice. Then the heavy lifting comes in, because now we have to match this incoming stream of ticks against the number of ticks, number of alerts in the database. But we cannot go 12,000 times a second to the database, because that will not scale. But this component is basically responsible for matching the alerts. And if there is a match for one or maybe multiple customers, it will push another event basically on Kafka. So there are no API calls between those applications. It's all event driven. And that notification service is going to reach out to either a SMS gateway / platform or a push platform to, in the end, deliver the notification, the alert to the customer. So this is in a high level, actually what we built. And we're going to run this whole thing locally, so let's pray the demo gods everything will work fine. So let's switch to IntelliJ.
Yeah. While team is preparing to run everything, it's important to understand that the 12,000 ticks per second for Kafka, it's basically very lightweight, if you think. Kafka was developed to process really huge amounts of data. But our biggest challenge there is not only those 12,000 ticks, it's about matching 12,000 ticks per second all the time, because you see we trade from stock exchanges from all over the world, so it's all the time running, and we have thousands of alerts created per customers. And you cannot be behind, because if you start to get behind a few seconds, soon you're very behind, because you're processing a lot. So at the same time that you're processing those alerts, you have to match against the existing alerts and keep moving forward. You cannot stop, because that's always real time. For instance, when it's 3 in the afternoon, the New York Stock Exchange in Amsterdam, the New York Stock Exchange open in the US. And I mean, it's an ongoing thing, and that's one of the biggest challenges we have. Yeah. And also, other important factor, while everything is starting over there, Tim is going to explain and do a nice demo about this, is Kafka fits very well with the Spring Boot model, because you have control of your application instance, and you have, you can scale multiple applications, and Kafka delegates this scalability, basically if you have the proper number of partitions and etc., to the client side, so you can have control over how you auto-scale and downscale your applications. It's really a very good match, because if you compare Kafka with JMS and the old way of doing it, it really gives you this perfect model where you can manage and prepare your application for different payloads during the whole day. So it really fits very well if you think about it.
Still starting up. Let's see if the demo gods are with us.
Yeah, there's one specific thing about this demo. We don't go in deeper details about Kafka itself. I hope everyone, I believe all of you have some understanding of Kafka, and but it will be like a demo on top of it. We're going to talk about streams and about how we do joins and how we manage all this data in more details and show a lot of code.
Yeah. So what I actually did, I started our set of Docker Compose files. It started Kafka, it started Zookeeper, it started Prometheus for our metrics. Marcoss is going to show that later on. What else? A database, of course, Postgres in this case. And we Dockerized all our Spring Boot applications to basically start this thing up. Okay, everything is healthy, so far so good. So in the next demo, we're going to create a lot of ticks, price updates on stocks, just to mimic the market, because we are not connected to a real stock market, third-party provider here. So we basically mimic this, but just for this demo, I don't want to do this, because I would like to show you the flow through these applications and do these topics. So what we're actually going to do now is to mimic a customer. Just for you to know, showing you on the mobile phone is a bit strange, right? So for today, the notification, the alert will be delivered by mail. So you can all see it. And just to show you, we're not tricking you, the inbox is empty. And let's see if it works fine. And we are really, really lazy backend developers. So for today, our UI is Swagger. I hope you're all familiar with it. So we're going to create an alert. So today, I'm customer 12345. It's one of our most beloved customers. And I have an Apple stock in my portfolio. And we just looked up the price of an Apple stock. It's going down actually a bit. Let's see. So this is the actual price. So let's copy this price. And we're going to create an alert in the system. So this is the base price. I should replace this with a dot. So it's almost 200 euros. And yeah, we all would like to get rich, right? So if it reaches a price of $3,000, then I would like to get a notification. Let's see if that will happen. Each stock has a unique kind of symbol to identify a certain stock. So the symbol here is AAPL, right? That's the Apple stock. So let's create this alert in the system. Let's see. Just to show you, we're going to load all the alerts for this customer, 12345. And here we are. We created, I don't know if it's visible in the back, can make it a bit bigger for you. We created this alert, and if the stock price reaches 3,000, or of course higher than 3,000, we will have a match. But now we don't have ticks coming into the system. And actually what we do locally, we also don't want to connect to this third-party provider, because we will be flooded with a lot of data, right? So most of the time when we develop features, we would like to be in control of the ticks that we send. So we created our own kind of Kafka console producer, really specific for our case. So we can control the price of the stock at that moment, mimicking the stock market. But it's only one tick, right? Just for this demo. And ta-da, today it reaches the price a little bit over $3,000. It was traded on the Nasdaq exchange, and this is the symbol. So let's run this console producer. It's actually a Spring Boot application. It's not a web application. It's just a command line runner that we can execute here. And we basically say, produce this tick on a Kafka topic for the Apple stock, and basically send over this JSON file that will be converted into Afro later on, but we will go there soon. So. Let's execute this. The command line runner will start, publish the tick on Kafka, and now we should have a match, right? So let's take a look. There we are. There it is. So basically, the customer now received a notification on his phone. In this case, of course, it's Gmail, but just to show you the example, right? So everything was fine. What happened under the hood? Quickly going to show you the Kafka topics. We will go into depth later on, but just quickly add a few on the cluster. Maybe you can explain in the meantime what this tool does.
Yeah, this is a tool originally developed by Yahoo. That unfortunately it's not there anymore, but it's quite simple to configure. And because we started a few years ago, probably you can. There are very nice new tools actually, but because we started many years ago, this was one of the best tools for us to run it locally and basically to be able to keep developing with Kafka. And then we just use it, and it shows you the broker and the messages, every topic, the partitions on the topics. It's quite interesting too. and still available. It's Dockerized, so you can go to Docker Hub and download the image and just start using it, and that's amazing for us.
Yeah. And the really nice thing is that this is basically a view on top of your Kafka broker. It can be multiple brokers, but you see the Kafka topics where all the events and all the data is basically flowing around. It takes a little bit of time to...
It's 30 seconds by default. It goes to the broker and updates itself, of course, so usually it should show there at some point. And yeah, we just have to wait 30 seconds. Yeah. On the last column here, you can see.
Exactly. So we started off by creating this alert. So an event will pop up on a Kafka topic. Then the matcher picked it up. There was a match, sent also an event on another Kafka topic. And in the end, our notification component sent, in this case, the alert. So there was an event sent. An event, and what we did was we basically put a raw tick on one of the Kafka topics to basically kickstart this whole flow. So this was in the end the whole flow to the system, to all the topics and all the Spring Boot applications. Before we continue, I'm now going to shut it down, and we're going to start producing around 5,000 to 8,000 ticks automatically, and we're also going to mimic customers creating alerts in the system. So we're going to burn some CPU cycles here to mimic, because this is one simple example. So let's shut it down. We will go into the Docker Compose file, the whole setup later on, but this was just the quick demo.
Yeah, the key here is the high performance of Kafka for us, right? We need high throughput. And Kafka, it's very well thought. It's exactly for this type of use cases. The latency is very low because it uses like a zero copy approach. So it basically copies things directly from the buffer to the network buffer and sends this over the wire. So it's extremely fast. In this case, we're running the whole setup in multiple Docker instances. That's we also had a lot of experience with Docker and Spring Boot, and so basically it was a very good fit for us, and that's what we use for development. It really helps because locally you can basically simulate the whole system, which can be complex sometimes. I think most of you probably are using Docker when you talk about this. But let's go back to the presentation a little bit. Okay, so one of the key things for us, of course, it's about the metrics and monitoring. So when we start this project, we have to write this, but we need insights. And we start looking around at what we're going to use. And we saw Micrometer, and it's a library that it's not built specifically for Spring, but it's a pivotal project, but it's built for agnostic. You should be able to use it in any type of Java applications. But it fits really well with Spring Boot. It's basically very well integrated, and it makes it a bit easier if you're using Spring Boot, like many other libraries. It's like SL4J for metrics. It's you can measure basically everything. Yeah. So one of the key things for us is that we wanted more than only the normal metrics we have. We want business metrics on that, because we need to keep an eye when we send an alert, how long it's taking for actually for us to notify the customer. And you also want to keep an eye on between the nodes, how it's the latency between days. If you have some bottleneck, we want to immediately know where the bottleneck is, so we can scale that layer specifically. Of course, we can automate that as well, but you also want the visibility, so you can improve your algorithms between the flow and things like that. So this was really key for us. And for you to understand a little bit this part, so let's imagine this is a stock exchange, a bit about metrics. So the stock is traded, so you do a trade, you buy stock. This a tick is emitted. We do an ingestion of this tick. That's what we call a raw stock tick, and we produce this tick to the first Kafka topic. But when you think about this, the raw data from the market does not fit your internal systems. So the first thing we need to do is to enrich that data with something that adds meaning that can be used by our internal system. So we have all the business intelligence on top of it, and that's the first step of it. So what we do is we have a huge group of business experts that they keep all the stocks we trade. Currently we trade over 40,000 different kinds of instruments, just for you to have an idea. Basically, if you want to buy stock, we have more than 40,000 different options to buy what you want. And we have to match this, because if we start to ingest this data in our systems internally, without this intelligence, they have no meaning for us. So this is the first step, and what we do here, it's basically is a Kafka stream and a K-table. I'm going to go in details about this, and we do the join, and we produce to the second, to the third topic here, where now all the data has a business meaning, and it can be used by all our internal systems. Once we do that, then of course we have a match engine, and if there is a match, we publish to another topic, and of course then there's a notification service that we actually send the information to our customers. I'm going to show a little bit about the monitoring first. Can I come here? Yeah. So let me show a little bit how we did this monitoring. I hope everything starts fine, because in this step, what the team did is he restarted the whole engine producing ticks, and we expect something at least 5,000 ticks per second here to show you how good Kafka can be to process this. So yeah, the system is fully healthy again. So I'm gonna do, we sync our metrics to we use Grafana, and we sync our metrics to Prometheus in this example, because it's fairly easy. And that's what we're gonna show you. So we have a Grafana board, and it's important that you keep in mind the picture I just showed you with all the steps, because that's basically what we should see around here. So we have this board with metrics, and it will take some time, because when it was initializing, the latency here is a bit out, but it's going to go out. But here we are now basically producing 5,400 ticks per second. We are processing that. We also have here a metric that you can see the average size of every tick, so this also helps us. And actually, this is the average size, this is the current bandwidth being used. This also helps us to be prepared if we need more bandwidth. Bandwidth can be something important on the stock market, because when there's a flush of stocks, you need your network to be prepared. So we need to know that basically all the time, so we can improve there and do some work on there. So this should soon go away, and then you see a more realistic graphic. The initial tick here took some time because it was basically restarting. We are generating some alerts. Of course, this is a smaller number because the load would be too high. But basically, there are matches happening, and alerts are being matched and sent basically immediately. And the latency is extremely low. So if we look around here, of course, in our real environment, we have more or less 10 milliseconds latency between the application where the server where the application is running and the broker. So you can just add 10 milliseconds in average per node, but that's it. That's basically the latency we have in real life. And here you can see more or less all the steps, what happens. So basically the first step, it's taking 1 millisecond because we generate the tick here and we process it here. But then we do the first step, which is that stream that we enrich the data, as I explained to you guys. And this is taking 50 milliseconds. It's the second topic. So this is the join happened. Then we do a match. This is taking now 105 milliseconds. And then we actually send the alert. So in this local environment, the time between actually matching, generating a tick, doing the match, and sending the alert, it's about 180 milliseconds. It's extremely efficient. And the other thing that's really important for us, it's about being scalable. ING is in a journey to become a global platform. So what's happening now, we're building our systems to now not be localized anymore. So we don't want to have like a system for the Netherlands, another system doing trading for the Belgium. We want a single system. And the final goal is to have the whole 40 countries using a single global platform to do this. So the idea is that we really go more in the direction of an IT company where you have a central managed per unit that can handle basically the full workload worldwide. And that's what the journey we're right now. So let me show some code, how this works. This is extremely interesting because Kafka has some features that really helps us to do this monitoring. And I'll show you how. First thing, the Kafka clients, they expose one guy called Matrix Reporter. This is a Kafka internal, and the Matrix Reporter enables you basically to plug in any type of monitoring system that you want and basically collect. So every time there's an update on some metric, understand that those metrics now are being taken on the client side, right? We're not talking about the broker, we're talking about the applications. And every time your clients they have an update on a metric, basically this method is triggered. It's a callback, and you receive the actual Kafka metric with all the data you need. And basically we get that value, and we publish to be showed on that board that I just showed to you. But there's more than that. Monitoring is a cross-cutting concern. You don't want that logic to be polluting your business code. Business code is really important in banking. We cannot make many mistakes there, so we want really clean code on that area. And Kafka also facilitates that. Kafka has a concept that is very familiar for you all, for sure, but I don't see people talking a lot about it. But you can use. I think I lost one of my bookmarks. I'll show you. Yeah, this one. So it's an interceptor. So Kafka also allows you to hook in interceptors on the topic. So you can say every producer will be an interceptor, and you can basically use that interceptor to get the data you need and get the metric from it. So you can really take it completely a part of your business code. So whenever there is a new message sent to a topic, it will be an interceptor, and you can also do that for consumers, for producers, and for streams. And when I talk about streams, important notion in Kafka that you need, it's important to understand. When you talk about streams, streams are a high-level abstraction around a consumer and a producer. So everything you can do with a consumer or for a producer, you can basically do with a stream as well. And basically what Kafka does behind the scenes, when you create a stream, it creates a consumer and it creates a producer for you. So it's also important to remember that, like if you set one thread for a Kafka stream, basically behind the scenes it will create at least 3 threads, usually 4, because it creates one thread for the consumer, one thread for the processor, one thread for the producer to push to a buffer, and another thread to actually dispatch that information to the network. So this is the metrics part. It really makes it very simple, everything we can get from Kafka. And I'm going to show you now a little bit about how we do that first match, just to make it more explicit. And we're going to see some code from that as well. The demo worked, so that's not okay. Yeah, okay. But I think this is back now. I don't know how it happened. It magically happened. Okay, let's see a little bit about Kafka Streams and joins. So the first concept here that it's interesting is we have a broker. And the first thing here that takes apart what Kafka Streams does compared to Spark or Flink is that Kafka Streams run in your own application. That's what I mentioned a little bit in the beginning. It's not running in an external managed broker and using external workers. It's actually running inside your Spring Boot application. That's why you have so much control over it, to scale, downscale, etc. So think about this like a Spring Boot application. And now we have a topic. That's the initial topic. Remember, in the first step, we get the topic from the market. We push to the initial topic. And there's a second concept here, which is extremely important, is the duality between the log on Kafka, because every entry in the log in Kafka have a key. And that key brings you you can think of like a primary key in the database. You can use that key to do joins. So when you think about every entry that goes to the log in Kafka, it has a key, and you can think of it like a primary key just to make it easy. Everyone understands the concept of a primary key, right? And then we have the raw tick. Then we have the second topic. This is where our business intelligence is. So the data we need to make this information that we get here useful for our internal applications, it's in a separate topic. And we use a concept called a global K table. Why we use the global K table? The global K table gives you many things for free. First of all, it saves automatically for you the last update in any key that you push to that topic. So if there's any update from an external system to this topic, let's say our business analysts, they now remove a specific tick that we don't trade anymore. So we cannot trade, or there's a new type of instrument that we want to trade. When this goes to this topic, it automatically saves for you. So think of it, and look, this is running in your local application, which is great here, because basically you can use this like a cache, but it's much simpler than a cache. Now you don't have to manage anymore, like when you have to put or delete from the cache. You get all this for free. And what Kafka does, it materializes that in a RocksDB instance by default. You can also use a different key value store here if you want, but that's the default one. Extremely performant for SSDs. So another point to keep in mind, running SSD environments. And now you can basically do a join here. So the flow here is constant. This is a K stream, so this never stops. There is a new stock exchange opening. There is never stops. It's 24/7. This data, it's a bit more static, but can also be updated as you will. The performance here would be great even if you have many updates in this side, but in our case it doesn't. And what you do, it's a simple join like we all see. And finally, when we do the join between these values, we push to a topic where now this information makes sense for our internal systems. And from there we continue. And remember, all this, it's flowing here, thousands per second, it's joining, and now this is taking 100 milliseconds or so all the time. And that's one of the benefits of it. But please keep in mind this side and this side, because I'm going to show you the code that does that. And that's another part that's quite interesting, because it's quite simplified by Kafka. Yeah. So can you, I don't know if it's good enough. Oh, yeah, end the show, good, thanks. We're almost there. Okay, yeah. So I'm going to show you, there's some configuration around it. I probably saw the talk yesterday about Kafka. You can do configuration around it, and then basically I'm going to show what's really important here. It's the focus on what we're doing. First of all, of course, because you are deserializing the information from one topic and serializing to another topic. Basically, we're deserializing, serializing. Then you have a SERDE, serializer, deserializer. That's the name SERDE. And then you have an Avro type. This is an Avro schema. Avro schemas give you a lot of advantages. We're going to comment a little bit more about this later. And then this is your global K table. What this does, it's reading for that specific topic and is basically materializing it locally in your application with a specific key and with a specific Avro type. And this is all you need to do to have your cache. If there's an update on that topic, you can just send a key with a null and it's deleted for you. If there is a new value, it's automatically add to you to that local cache. And this is running locally. And when I mean running locally, because this is extremely important for us as well, a get on this key value store takes nanoseconds in a server, less than 0 milliseconds. That's our experience on that. It's extremely fast. It's locally. The RocksDB also has local cache. So in the end, is everything running in your local application. It's extremely efficient. And then we do a K stream from the other topic. That's the continuous flow of ticks. And that's what you need to do, these two lines. And then you do a join. And now you do a join, and you say by symbol, and you do that join. And once you do the join, if there is something, it will basically sync to the next topic. And then you do two, and this sends to the new topic. And on top of that, what's quite interesting here is that our applications, they also need that metadata that's generated by our business people to be used in different parts of the front end and etc. And you can actually add, basically, I need to scroll a bit. Basically, you can, on top of that global K table, you can expose those values as a key value store in 2 lines of code. So now you have here all the metadata that you need, the join, the enrichment of the message, and you can actually expose all the data. We do the same for the price, by the way. So when you go to the applications and you see the stock price, we're doing basically the same. We expose the price from a K table, and this is extremely performant as well. From there, we go back to the presentation, and Tim is going to let's go over this. Tim is going to talk a little bit about our local development setup.
Yeah. So you saw already some quite advanced topics that Marcoss showed us. Maybe you got inspired by Josh Long yesterday and Victor from Confluence. They are really great in creating Hello World scalable applications. With all respect, I really like those talks. But you probably go back to work on Monday, so maybe you got expired. So if you would like to use this stuff, where do you start, right? So because we're a bit struggling, let's say if we go back 3 years ago. So we started out with Docker to run everything locally, because of course we have a Kafka cluster on test environments, on dev environments. But yeah, if Marcoss is going to create or publish a lot of data on a topic, I might also consume that data, and yeah, we stepped on each other's toes quite quickly. So we decided to isolate our environments, run everything locally. We initially started with creating our own Docker Kafka images, and along the way, Confluence, the company behind Kafka, nowadays provides you with nice Docker images, also for Zookeeper, Kafka Manager, and we Dockerized our own applications. As I mentioned, this custom producer is quite important for us, and this whole project grew into a lab project that we basically use every day in our work to try out new stuff. We can break everything, and yeah, the things we learn there, we bring it back to the real project within in ING. And it's also a really nice experience for us to learn more about the latest and greatest in Spring Boot and Kafka. Let's go to some code. Let's go back to IntelliJ. Yeah, so hopefully you're all using Spring Boot. Then it's really easy to get started with Spring Kafka. You just drop in the Spring Kafka dependency. Let me show up. We're still running, right?
Yeah, it's still running.
So it's a bit hot here. It's fine. Okay. Let's show commands. Okay. So let's make it a little bit bigger. So this is an example of our Docker Compose file. So Confluent provides us with this nice Docker images. There's of course a lot of configuration around it, but yeah, you will learn along the way how to do this. We use a schema registry, and Afro schemas are basically the contract between the consumer and the producer, and they are stored in this registry. We run a Kafka manager, that's the UI on top of it to see what's going on. We use Postgres as a database, and we have the Dockerized applications here. So that's how we basically start working locally. Most of the time we focus on one application running in IntelliJ, where we're working in, and the rest is basically running in the background for us, and that works pretty well. Okay. Yeah, then maybe a quick introduction in Afro. You need those dependencies to create, basically Java objects out of the Afro schemas. You can also use plain JSON, or we started out with Protobuf indeed. But there are it's really great to use Afro there because it enforces the contract between the consumer and the producer. So let's show you an actual Afro schema. So this is one of our events. This is an event when a customer deletes one of his alerts from the UI, and then we send this alert out of to the Kafka topic. And this is basically the definition. It's probably the most simple Afro schema we have here. So we have the unique identifier of the alert, the identifier of the customer, and the symbol that uniquely identifies the stock. We have this Kafka Afro plugin basically for Maven, and it will automatically create a Java object out of it. Maybe you saw the talk yesterday, so don't look at that code. It's not really nice to read, but it works pretty fine. We just use this to push the data on Kafka. Then you, of course, would like to produce some data on a topic, right? So let's take a look how we actually going to produce data to Kafka. You are pretty sure familiar with all kinds of templates, right? JDBC template, REST template, and of course, in the Spring model, we also have a Kafka template here to produce to a topic. And that's basically, yeah, what you need to send data to a topic. So it's, in this case, let's focus on the alert deleted event. So this is the generated code, right, for Afro. And we basically say, hey, template, send this event to a certain topic, and here's the data. That's probably all you need. In the talk yesterday by Josh Long, he created a lot of stuff in Java configuration. Nowadays, you can also really nicely configure everything in your application.properties or your YAML. Depends on what you like. But this is basically the configuration. You say, here is my Kafka Broker running. You can have one or multiple, depending on your situation. This is the serializer for the key. And this is the serializer for Afro. Then we point to the schema registry. And this is something we need for the metrics that Marcoss just showed. So this is the producer side of things. And yeah, Spring Kafka will create under the hood a Kafka producer, because that's what you need to basically produce this data to the topic. On the other hand, you would like to consume the data. In this example, we directly also consume the data in a consumer. So this is the other way around. It's pretty straightforward. Yeah, so let's look at a really simple consumer. This is an example where we consume a alert deleted event. You have a Kafka listener, and yeah, that will basically deliver this event to this method. You can even do a validation on incoming data, right? So that's not really specific to Spring Kafka, but it just leverages the good things that Spring and Spring Boot offers us. And in this case, we just call the meta registry from Micrometer. But this is a really simple example. You can, of course, call a downstream service or whatever you would like to do. But this is basically a simple producer-consumer example. I think that's
yeah, let's use the 3 final minutes to talk a little bit about lessons learned and share a few of the drawbacks and what we learned. I think this is quite important.
Is the screen back? Okay. Yeah, so we touched Spring Kafka. Let's go to the lessons learned. Yeah.
Do you have the... No, okay, it's fine. I'll stay here. So, a little bit. First of all, before using Spring Kafka, we recommend that you understand basically Kafka behind it. There's a lot to it. It's distributed computing. There are the complexities there. You need to know how to configure, how to scale. It's not only about adding nodes. You need to have proper partitioning. So this is quite interesting, quite important. Avro, it's really life-saving. Basically, Avro enforces a contract between the producer and the consumer, and basically you cannot push a message that's invalid to the topic. It really helps. From the business perspective, it can still be invalid, of course. It can have a wrong value, but the serialization and deserialization process is enforced and is guaranteed, because then the message will always be possible to serialize, deserialize. It's important to think a little bit about partitions before you start, basically because you have to think, if you do joins, the topics you're doing joins, they should have the same number of partitions with some exceptions. If you're using a global K table, like was the case, because everything goes running on the on the client side, this can be a bit different. But if you're doing, for instance, a normal K table and you want to horizontal scale, then you really need the same number of partitions between the topics. And this is one of the key important. And also, if you want to scale Kafka, our thought is possible. It can be hard to do without downtime. And in our case, we don't have that privilege to have this downtime. So that's something important for us. Monitoring is extremely important. We use Micrometer. We're really happy with it. Simple, easy to use, very easy to sync the data to Elasticsearch, maybe if you have, or Prometheus. It really adapts to many different types of systems that you need. A little bit about, we really like how the Kafka clients are backwards compatible. So whenever they deliver a new version of the client, usually you can just upgrade the client without waiting for the broker. And this is amazing. As a developer, is something we really love it, because we always want to be taking advantage of the latest features. And Kafka in general is backwards compatible between clients. Kafka Streams, K-table, global K-tables, iterative queries. I talked about this a little bit with you. It's important to understand the difference between them. Global K-table, if you need a lot of scale, can be tricky, because basically a global K-table is going to consume from all the topics available for that specific, all the partitions, sorry. And describe is really your friend when you're doing streaming. I have a few seconds, let's finish this. Kafka Streams gives you exactly once guarantee by configuration, which is amazing. If you know distributed computing, you know it's one of the hardest things to do. And in Kafka Streams, it's basically for granted, it's just a configuration. Plain header topology, try to make it small. A topology is a set of joins that you do between topics, because that's a single deployable unit. So if you want to scale independently, it's important that you plan ahead this topology. And yeah, that's it. Thank you very much for being here.